Fluorescent lamps come in many different types. Our linear type, which is a tube, it's always going to start with that T, is going to be have a higher efficacy than a compact fluorescent, and compact fluorescents often have a screw base and are designed to replace an incandescent light source instead. The way that they work is that there is a mercury vapor inside the tube, and it excites the phosphors that are coating the inside of the bulb. They use a similar letter number, so if we look at the lights, the lamps to the left, the T5 is a miniature, so it's 5/8 of an inch in diameter. A T8 is a 1 inch in diameter. T12 is 12/8 or 1 1/4 in diameter, etc. Looking at some additional shapes in the compact fluorescent category, the efficacy is high for tube lights. It's around 100 lumens per watts. They last for a long time, so we get around 30,000 hours plus or minus out of a tube fluorescent light. The color temperature is listed as either being warm, medium, or cool. They do have a lower CRI for the most part. They are inexpensive fixtures, which is why we see them quite often in commercial spaces and garages and places like that. The tubes themselves are fairly inexpensive. The downsides of fluorescents are that they are thermally sensitive. So you can't have them in too hot of a temperature or too cold of a temperature. And actually, speaking of grocery stores, the advent of linear LEDs being cost effective has made a huge difference in the frozen section of our grocery stores, because we couldn't use tube lighting in freezers. So when you open the door, it didn't work to have fluorescent lights. It was too cold. They also sometimes are not an instant on. It can take a portion of a second to longer for them to really turn on. And then you might have noticed with some of your fluorescent light sources that the amount of lumens that comes out when you first turn the fixture on compared to half an hour later or an hour later, it really takes a while for them to get up to their full force. And that's one of the reasons also why fluorescents are not considered to be as good of light sources for areas where you might be turning the light on for a short amount of time and then turning it off again. They require a ballast to limit the amount of electricity that runs through them. They run at a low voltage, and unlike halogens, the voltage has to be dealt with in the fixture for the most part. And it's one of the reasons why if you have a fixture that's designed for fluorescent lamps, you can't replace it with another type of lamp. It has to be a fluorescent for the most part. Also, it requires a special type of ballast, which is quite expensive to provide dimming. So if you have a light fixture that's supposed to dim, and you put a compact fluorescent bulb in there, lamp, instead of an incandescent or halogen, it's not going to dim the way that it should. Also, another downside of fluorescent is that they do contain mercury. Mercury is a neurotoxin, and mercury is something that can get into our water table pretty easily. You might be aware of the fact that a lot of fish in the ocean have higher levels of mercury than is considered safe, and it's suggested that people limit their intake of certain kinds of fish, especially tuna, if they're pregnant or for children, because of the levels of mercury. If you do have fluorescent bulbs, they are required to not be thrown into the garbage, but have special disposal. There are places that will recycle them for free. The best uses for fluorescents are a workhorse for general lighting. They create a wash of light across the entire surface. And typically our light fixture is what helps direct the light in a specific direction. Compact fluorescent lamps, which might have a 2-pin base like we saw with some of the halogens, or a screw-in base because they're designed to replace incandescents, are not as don't have as high of an efficacy as our tube, but are still pretty high. The lamp life tends to be shorter than for a tube. They have the same color temperatures as tubes, the same CRI as tubes. They have the same pros as tube lighting, the same cons as them as well. And yeah, the main purpose of our compact fluorescents is to replace incandescents, and they tend to be seen as more of a point source. So a specific place where light is emanating from, as opposed to a linear light source such as tube lighting provides. So, as I mentioned, in a light fixture that's designed to be used with a fluorescent lamp or fluorescent light source, a ballast is required, and the most common type of ballast is an electronic ballast. We're going to look at 3 different types. The purpose of that electronic ballast is to provide a high initial voltage to initiate discharge, then rapidly limit the lamp current to safely sustain the discharge. Ballasts are required of all gas discharge lamps, and it has to do with creating a high amount of voltage and then lowering the voltage within the fixture itself. Now you might be wondering about compact fluorescent bulbs, which are designed to replace incandescent bulbs. And you might have noticed that the base of that compact fluorescent is very chunky compared to the incandescent, and that's because there is a ballast built into the base of it so that it's controlling the voltage to give the instant on, and then lower the voltage to keep that phosphor working the way that it's supposed to. So of the types of electronic ballast that you would find in a light fixture designed for fluorescent, the 3 main types are instant start, rapid start, and programmed. With the instant start, again, we get that voltage spike to start. It creates an instant on, which is what people tend to like. There was an older type called a magnetic ballast, and for those of us who are old enough to remember, that's when you get the flicker at the beginning when it first turns on, and then because it's cycling through, there can be a flicker when there's a magnetic ballast that can cause people to have headaches, even epileptic seizures, and so we don't see them anymore. With the instant start, comparatively between the three, they are fairly efficient in the amount of electricity that is required to operate the ballast itself, but that spike at the beginning to turn on does shorten the lamp life of the fluorescent tube in most cases itself, and for that reason it's not as good of an option for a light fixture that needs to be turned on and off frequently, because every time you turn it on it's zapping the lamp, which can reduce the overall life of it. Rapid start is used in places where we want that better on-off, not lessening the lamp life. It also is an instant on, but with a rapid start as opposed to the instant start, there's a brief moment between turning the switch where there's no light as it is creating the setting that it needs to within itself to get the phosphors to fire. And because it is preheating as start, it's less efficient. It's using more electricity in the ballast than the instant start. However, because it is not stressing out the lamp itself, the light source, it's considered to be often a better solution for places where people might be turning that light on and off, so that we're not replacing the tubes, the fluorescent lamps, as often. The third type, excuse me, the programmed type, has the maximum lamp life out of these three, and of course it's going to be the most expensive type of ballast. It is also the best for efficiency, and it's the best for on and off. And whenever we see an occupancy sensor, such as a place, public restroom or office space, typically it's going to be a programmed ballast.